Hello guys, I am Achan. Today we are going to do a Proteus plus an Arduino session. In Proteus, that in the Proteus simulation software, usually if you are new to Proteus, you couldn't able to find, means you can't find a Arduino when you search from a PK library. So just we can search whether there is an Arduino present or not, so that we can add here, like as you add LED. For example, when you want LED, you type LED and you will add LED by double clicking on this components. So you can use it later. Similar way, we can search Arduino. Arduino. Okay. So here we can see some things. Arduino DIL, but these are not Arduino boards. Okay, so there is no board like Arduino. Like me, you can also find you cannot see Arduino within you because Arduino library is not added in Proteus. So we can let's go to how to add a library, means any library like Arduino library or any other library that is not in the, means if any of the component you found that is not in the Proteus, you can search in the net, and you can, if anyone had produced a library or anyone made the library, you can download that and you can add in the Proteus. So let's learn how to add a library in Proteus. I have already downloaded Arduino library from internet. So I will share this thing in the group, so you can see how it library has been added. So when you're opening, you can see two names. These are the two libraries, means two texts that present inside it. We just copy only the two things. Okay. And the instruction of the text is provided generally instruction how to add a new library if you are using Proteus 8 or Proteus 7. Either you can follow this or you can follow what I am showing in the video. Okay, so I have copied both Arduino to .idx file as well as the lib file. Then go to your PC and you have to, usually you will see like this, but there are some hidden files. In order to see the hidden files, you have to go to use and tick hidden files. So the hidden folders will appear. From there, go to program data. Okay, program data. You can see here program data. Then you can search for Lab Central Electronics, and you can find Proteus 8 Professional, and then library. Then paste it there. Ctrl+V. I'm pasting there. So you can see the libraries are added. So these are the Arduino libraries. Okay, so I have added Arduino. Then let's restart our Proteus. I just closed the Proteus, and now we need to restart it. So go to schematic, pick a library, select P, then search for Arduino again. Arduino. Okay. Now you can see some new tests is Simulino, Lilipad, Simulino Mega, Nano, Uno. These are added. You can see these are Arduino boards, different varieties of Arduino boards. Mega, circular like Arduino boards. Nano, that is smallest Arduino board. Uno, this is commonly common type of Arduino that we are using. So now we got an Arduino. So today you learn how to add a library to a Proteus. Similarly, if any other components, if any other any electronic components are not present, if any ICs are not present like this, you can add libraries that are already produced in the internet through this method. Okay, simple, right? Just copying the files in library folder, but make sure that you have to enable your hidden files to view your hidden files, and in the programs data we are adding the library. Okay, in the Proteus, then library, then we are adding the Arduino library. Click double click, so you can see Simulino on the left side. Then we can do with some LED. You can start with the glowing an LED. So this is not, I want a blue or green. Okay, blue LED we can choose. Then then we need what? Okay, this much we already need. So select an Arduino. You can rotate here, clockwise, anti-clockwise, anywhere. Okay, I'm just keeping as such it. Just okay, I placed here, and you can zoom in here, zoom in, zoom out. Okay, then I took an LED, then paste it here. Now pasting out, it is just click and just click here. It will come like that. So I'm connecting 13 pin of Arduino. So this is the default pin for glowing LED for Arduino, as you don't go through many sections about Arduino. So connect the wire, just double click there, the wire will come like this. Just double clicking, the wire will come, and just clicking there, it will bend, and it will bend like this. So it is just like that. Okay, in order to remove that, just put escape, it will go. Now you need a earth for connecting the ground. So go to terminal mode, pick ground. So you can see the label over here, and just select, just click anywhere, so it will come. Click again. So now click escape, and now we have an Arduino with an LED. Now how to write code to blink this LED. Okay, so for this, everyone go open Arduino file, open new. Since most of you know how to glow an LED in Arduino, and means the code for glowing an LED in Arduino. So the same code is provided in Arduino itself as an example. There you can see many codes, like how servo, the code for rotating servo, like many rotating RTC time module, GSM, like this. So many things you can able to see. So for seeing the example or seeing the example codes, you can go to files, see examples, and these are all our examples. We can just go to basics, just blink is just for that blinking of LED, that we are creating high, then delay, then again keeping it high, no, low, then again delay, like that. So this you can find here. So you can see this pin void setup. Inside the void setup, you are defining the pin, that is LED bulletin. If you wish, you can, even though you upload this code, if since Arduino have default 13 as its pin that for glowing the LED, it will glow. So you can change it to 13. So it will be output. Okay, then inside the void loop, we are just digital write, that we are giving a digital output, that is high, then delay for 1000 milliseconds, that is a second. Digital write, you can choose this as 13 again, 13, and low, then delay seconds. So okay, now you are done. And actually we are going to verify the code, and we are generating an hex file. That hex file need to be pasted in Proteus. So for generating that hex file, everyone need to check whether you have ticked the compilation. So for that, go to files, preference. Here you can see compilation. So just tick the box, click OK. Okay, in your IDE it won't be ticked. You have to mark a tick, and just click OK. Now you can generate hex file by just verifying the code. Since you can't upload the code because we don't have a physical Arduino with us, so it is just compiled. So done compiling. We can move the slider and search for hex file like .ino.hex. That is the file. So select the path of the file. Don't include double quotes. Except a double quote inside that. Only need to select it. You can see I just copied. Go to Proteus again. Then double click the Arduino. Double click. So it will open a file like this. Here you can see program file. We can paste it here. Just paste it. Okay. Click OK. Now run. This is for running the simulation. Run it. Yeah. Gloss off. Gloss off. So this is a basic how to glow an LED in Proteus along by using of Arduino IDE. So just simple. I mean, you're coding everything in Arduino, and after you are done the coding, you are just verifying the code and you are just pasting the hex file in Proteus. And make sure that while you are running your Proteus simulation, the Arduino sections are open. And so that blink, if you are running the blink program, both that are open. Okay, so that you have to make sure. Hello guys, next section is on how to use a motor driver or how to simulate a motor driver in Proteus. So before going to do it in the Proteus, we can just look at about motor drivers. So usually we use motor drivers. Okay, I will explain. So you know that when you power the motor, if you have a simple DC motor, when you power the motor, it will rotate in forward direction, and if you turn it, if you reverse the direction of the current that you're giving, it will rotate in backward direction. So every time you have to reverse your switch your wires, both positive and negative, like that, not to rotate forward, not to rotate the motor forward as well as backward. So and we need this which is a kind of a difficult task. So here, so for this, here we need some kind of a drivers, like that is motor drivers, and the commonly used will be L293D driver. So by giving a different input at a high, or means applying high voltage, since they are connected in such a way that applying high at different positions of the this chip, we can able to rotate the motors forward as well as backward without switching the wires. Okay, so that is the one application of that is where we need a use of a motor driver like L293D. So I am also going to explain about L293D. So in the L293D, when you are just looking the data sheet of an L293D, you will find like 16 pins, and 16 pins. And in order to activate the left side, okay, not to activate the left side of this IC, you can see this is the left side. Not to activate the left side of this IC, you need to provide a high voltage to the enable one. So that is the purpose of enable one. So in order to activate the other side, on the right side, you have to provide a high voltage at the enable 2. So that is the purpose of the enable pins. Then, so anyway, you have to control your motors. So you are giving an input source, which I said you can able to control your motor by giving high or low, like that, applying suitable voltages. So this is your input pin. Either you can able to control your motor. So that is input pin 1 and input pin 2. If you give high as well as low, like this, giving a high at input 1 and low at input 2, the motor will rotate clockwise. Okay. And if you here it's input 2 as high and input 1 as low, the motor will rotate anti-clockwise. So this is what I explained earlier, that we can rotate the motor clockwise as well as anti-clockwise without changing the bias. And usually servo motors requires a high power. It won't it means it can't work in 5 volt. It requires somewhat higher powers, so about 9 volt to 12 volts. So that's why we are providing a pin here. It can able to provide a source of 9 volt bar 12 volt. Remember that this 9 bar 12 volt is not for working of the IC, means working of L293D. It's not IC, sorry. For working not it's not for the working of L293D. It is just for the working of the motor. For working of the L293D, we need VSS. That is only the 5 volt is only required for working of this L293D. That's why here they are given 5 volt, and on here it's given 9 volt or 12 volt battery. Okay. Similarly, on the right side, we have to control the motor. So similarly, there are two input pins, input 3 as well as input 4. If you give high or input 3 and low or input 4, it will rotate clockwise. And when you reverse it, that is input 4 with high and input 3 with low, it will rotate anti-clockwise. And I think you got what is output pins. So since you are applying input, you have to provide signals according to the input. So for getting the current to move according to the input signals, the motor should be connected. So other two ends of the motor should be connected in. On the left, it is connected with output 1, and on the and output 2. On the right, it is connected with output 3 as well as output 4. Okay. And here it is grounds are provided, that is 4, 5 as well as 13 are grounds. This is ground pins. Of course, you can able to use while you are connecting battery. You can connect one positive end of the battery and ground with any of the grounds. Okay. So I think now you got what is an L293D, what are its pins, and why we are using, how we can able to control your motor. Okay. So the condition I mentioned here is forward condition. That's in order to drive your motor forward, you have to rotate the motor. Two motors. If you imagine that these two motors are the tires of your car, front tires of your car. So this is the left tire and that is the right tire. In order to rotate that thing, you have to move both the tires forward. So for rotating this thing clockwise and this thing also in clockwise, you have to give high at the input 1 and low at the input 2. So the current will go from high to, that is high to low. So guys, sorry for the interruption. So yeah, we have stopped here. So in order to rotate the motor forward, again we have to give input 1 and input 2 with the high, input low, input 2 as low, and input 3 and again input 4 as input 3 as high and input 4 as low are going to move rotate forward, so that tire will rotate forward. So other conditions are, in order to move the backward, that means okay. In order to move backward, the condition, what is the condition? You can guess. I think that input 2 will be that in order to move the current in opposite direction, you can give input 2 as high and input 1 as low. Here input 3 as low and input 4 as high. That's just the vice versa of forward. Then in order to move the left, you have to you can think that how you can move the how you can turn your entire vehicle to left, that you can rotate your right and keeping the other tire as rest. So that is I'm keeping my left tire as rest, that is low. That means the motor won't work and it won't rotate in any other direction, and the motor will only rotate forward in for the right motor. Only the right motor will work. That is input 3 is kept as high and input 4 is kept as low. Okay, that is while rotating the right tire, you can able to move to the left. Okay. So next is how to move right. So in order to move right, you can keep the right tire as low, means that stop rolling, and the left tire can be rotated, that is can be moved forward. That is input 1 is provided with the high and input 2 is provided with low, and input 3 and input 4 are low because they have to keep it low for rotating, move it to the right. And finally the stop condition is keeping all the motors low. That means no current is passing through any other rotor, that is no motor will rotate. So this is This is the working of motor driver, and how we can able to control the motors, two motors, how we can able to control two motors. So let's move on to the Proteus section. So I am just deleting this LED and this ground, because since you can just click that thing and just right click and just delete object. Actually, I have to that to ground. Okay, it got deleted. I need Arduino, so I'm keeping it Arduino, and you can double click and select to, if you want to position it, double click and you can move. Okay, if you want to position like this, and just again go to the component mode, because that is already in terminal, so I am just moving to component mode. So again, go to K library. We need L293D because it is a motor driver that we are going to use. L293D. Sorry, L293D. 3D. So we got it. So this is you can see the schematic model here. Just click it. Then we need servos, that is DC motors. You can just type motors, motor, and you can go with motor DC. You can see that. Just double click the DC motors. Then okay, you only need this much. Just click OK. Now you can select the L293D, place it here. Okay, I place it. Okay, this is the correct configuration. And if you want to move, just move it. Then just move it down. Okay, now I'm taking my DC, and here you can rotate. Keep your motor like this, because polarity matters. If you keep it in other way, it will rotate in other ways means instead of rotating backward, it rotating backward. So keep the two motors like this, because the green color should come here. That is on the left, the green color should be present. Keep it a little bit down. Okay, fine. Now we are just connecting the pins. So you can see here the pin don't worry about the pin configuration, they are same. It runs from 1 to 15, 1 to 16. That is from okay, it's enable 1 is there, enable 2 is there, input 1, input 2, input 3, input 4, output 1, output 2, output 3, output 4, everything is there, and VSS is there, VS is there, and ground. Here only one ground is there. In the diagram we have seen it has 3-4 ground, and now it doesn't matter anything. And think that in VSS we are providing 5 volt, and VS we are providing the a 9 bar, like 12 9 bar or 12. Okay. Then now we are going to make the connection. So instead of okay, we can go to make the connection. So output 1. So this is the first motor, this is the second motor, so this is the left motor, and this is the right motor. Okay. So and just output 1, getting a wire from output 1 and connecting to the end of the DC motor. Then okay, sorry. Okay, connected. Then from output 2, just connect to the other end of the first DC motor. Then similarly from output 3, you can connect it to the this end of the DC motor, and from 4 you can connect it to here. Okay, got it. Then now we are just going to connect the input pins, because they are used to control the motor. So I am just using digital pin 2 in the Arduino. Okay, you can see in the Arduino, you can see Arduino just to connect it to connect to the input 1. I think somewhere this wire is not coming. Why? Sorry guys, wire is not coming. Wire is not coming yet. Yeah, comes. Okay. So connected to 2. It is 2 is connected to the input 1, and 3 similarly. 3 connected to connected 3. Connect 3. to the input 2. So no, 2 is to the input 1, and from digital pin 3 to the input 2. Then from digital pin 4 to enable 3, and from 5 to enable 4. Okay, now we have enable 1 and enable 2 left, and the battery sources. So instead of providing battery, you can take the battery and you can provide a source here, but in Proteus we can use, instead of using the battery, we can use a power line. You can go to terminal mode, just take the power. So you can look at here, and VSS, you can see the diagram. We are providing the battery to the VS. Okay, so just move that thing to here, VS. Sorry, okay, actually that doesn't work. Delete that thing. Okay, power line again, then okay, VS, and just double click here so that you can edit here. You can type plus 12 volt. You are giving 12 volt battery for rotating the servo, and for working this L293D you have to give 5 volt. So I can take this 5 volt from the Arduino. Go there, it can able to provide the 5 volt, and just giving it here. Okay, now it's enable 1, enable 2. As in the last section about the motor drivers, they all said that in order to control this rotation, amount of rotation means how, and how it moves, means how much it moves fast. You can control it with the enable pins by giving at analog inputs. If you give digital input, the motor will rotate with both will rotate the same speed. That means you cannot able to control the speed. You cannot able to decrease or increase the speed. But if you are using an analog input, you can able to rotate. You can able to control the motor. So for that, I want a PWM pin. I have to get an input from the PWM pins, or output from the PWM pins. So I'm just taking pin number 11 and pin number 10. Those are the PWM pins, because in here you can see something that with a mark, like a similarity mark. You can see hyphen 11 hyphen 10, that are PWM pins. So through which you can able to control the voltage that getting into the IC, not L293D. So from 10 I'm giving a connection to enable 1, and 10 from 11 I'm giving it to enable 2. Okay, so now here left with an ground. So we can again go to component mode, terminal mode, take the ground and place it here. Okay, now our connections are complete. Okay, now our connections are complete. Now just go to Arduino. So I am just explaining the code. I have already provided the code in the group, so you can go through it. You can download it and you can use it. So this is the code. As I said, the input line 1 is connected to the digital pin of Arduino 2. So I am declaring input 1, 2, input 2, 3, input 3 connected with the 4 of Arduino, and input 4 is connected with the 5. And enable 1 is connected with 11, enable 2 is connected with I think we connected 10, which is 11. Okay, and enable 1 is connected with 10, and enable 2 is connected with 11. Now I will explain why we are just using this character. Now just display because we need this character. I will explain. You can see how it is used. So just typing like in declaring a character. Now in the void setup, you have to define what is its function, say either output or input. This pin mode input 1, that is digital pin 2, 3, 4, 5, 10, 11 are outputs. Okay, you are giving signals. So that is declared. Then come to the void loop. And since we said that enable 1 and enable 2 should be analog, so we are passing analog signals, and since we are connected to the PWM pins, we can able to control the amount of voltage. So its value will ranges from you can see here digital write in it, and we are getting high. Instead of that, we are getting, in order to control PWM pins, we are just writing it as analog write. You have to name the pin enable 1, then you can type the value from 0 to 255. That is a range of value. 0 to 55 correspond to the high voltage, 0 corresponds to the low voltage. If you provide a value in between 0 and 255, you can able to control the speed. So I am giving enable 1 and enable 2 both as 50. Okay, then and I will explain this also. You will like after coming this, and now we can look at a forward condition, digital write, that input 1, input 2. For moving the robot forward, the input 1 is kept at high, input 2 is kept as low, input 3 is kept as high, and input 4 is kept as low, as you seen in the figure here. That is, input 1 is kept as high, input 2 is kept as low, input 3 is kept as high, and input 4 is kept as low. So this is the same condition that I used in here also. So similarly for the backward, input 1 low is the reverse condition of this. In the high will be replaced with low, low will be replaced with high. And for moving the left, you have to keep the right part low. So that is the input 1, input 2 is kept at low, and the other two are kept at a high low forward condition. And similarly for moving it, so this is condition for moving the left, that is the right part is kept at low, and the left part is kept at low, and the right part is for forward motion. And similar to moving into the right, the left part is kept at high, low, and other is low, and for stopping everyone should be in low position. And now we comes with the character. So we have defined a character. So this is just for demonstrating a forward motion, backward motion, a left as well as right motion in Proteus. So if you giving a character it has 1 or 2, and if this condition satisfies, if I am giving the character c is equal to 1, so this is just hard coding. You can give value here, and you can just verify, and just you can see the result in the Proteus. Okay, if I am giving 2, this condition only works, that the bottom motors will move backwards. If you give C1, if this condition while running the code, if this condition satisfies, it will move forward like that. Okay, so I think the code is explained very well to you. So now I am going to just verify this code and generating hex file. So can just lift that thing up and then search for the .in or .hex. Okay, so I found that. Just copy that, then go to Proteus, then just paste it over there, and remove the earlier file, because those locations are not, you have to remove, you have to give a new location. Okay, then just simulate it. You can see the motors are moving backward. This is because on the character I gave it a c equal to 2, so that's why it is moving backward. So you can see the motors are moving very slowly. Its RPMs are very slow because I gave in the this enable 1 and enable 2 are provided with a value 50. That we can range the value from 0 to 255. I will provide at 50, so that's why they are moving slowly. Okay, and outputs are coming like this. And we can in order to test it how it move backward, we can just stop the simulation, and we can go to the Arduino code itself and change c equal to, I'm giving it a 3, because when you give 3 it will move left, and 4 it will move right, 5 it will stop. So I just give it as c is equal to 3. Again, just verify, just need to verify only. Verify the code, no need to copy again, because the same files are there, because the location of the Arduino code is same. We are just editing the code only. So once you verified there, you can again run here. No need to copy the hex file over here, no need to copy here. So just run it. You can see we have chosen 3, that means moves left. So what happened, the right side will stop and no, the left side will stop and the right side will move. So I said this is left and this is right. Sorry, it's some kind of error in Proteus. It's encoded by me. So for your understanding, I'm just adding the test here. So you can just go to anything. Is it 2D graphics line? So graphic line, just 2D text mode. Okay, this is the text mode. So we have chosen the letter A like this, not here. Okay, just type something. It is, since it is left motor, just type left. You can change font anyways, in just height like this, then over there. So it left, then over here you can again select, just type tap there, just tap there. You will get another box. Just type right. Just if you want to increase height, or in font you have to choose, you can choose the font. Just click OK. So the right button. So when you again type, you can again edit it. Now not to move it, you have to just click left click, right click, just drag the object, so it will come. Okay. So this is sorry. Just so I hope got it. So we missed one component. In earlier my simulation got stopped, and so that's why I had to. Okay. And we also here I lost one component. That is with the 5-volt battery. Okay. Then one, I think we have connected with 11 to no. Escape. If you done anything wrong, just click undo, just Control plus Z. Okay, you will get something. So here you can put enable 1, then 11 is connected to the enable 2. This is because earlier the simulation got stopped. It's some unknown error. I don't know even why the error causes, because maybe with the installation.